So I'm going to talk to you about a topic which is a little different than the previous two talks. This is a topic which is not specific to the CBB and some of its efforts, but it's trying to introduce or to remind you of some of the tools out there which may really help you to manage the data, to manage working in collaboration and teams, and to also manage other kinds of information in form of files, software, etc. So the idea is, I'm going to tell you a little bit how version control can help you really take charge of your collaboration data in the CBB and other research efforts. On the first slide, I just had some fun summarizing some of the tools that are out there. And for those of you who grew up in the later part of the last century, you realize how many more software tools have been developed over the last 10, 20 years and widely distributed, because this is just a subset of the ones we're using in our group, and you've probably seen and used a subset for some of those. Those include the, just a second, let me turn my pointer on. Those include some of the software packages we're all using. If you're a little older, you probably remember Fortran. If you're a grad student or postdoc now, you probably have seen or used Python. Those include some of the database systems and some of the libraries we're using when we develop software, etc. What I'm going to talk today is about two main tools, Git and GitHub, which allow us to use version control to better handle our data. And so the first question I'm going to ask is, why should I use version control? And so the simple and quick answer for that, it will make your life easier. The explanation is given in that cartoon because all of us, when we look at our files on our laptops and desktop computers, will probably have folders where you have files in there with crazy names like this, where you try to put in a budget together, and you made some changes, you wanted to keep the previous version, and you started naming them different ways. You start quite organized, you call them version 1.1, then you decide, oh, this is probably the final one, you add final, then you say, oh, there's a newer version, let's call it last version, and then you keep on going with that until you end up with a set of files and you have no idea which one was what and why you created all of them, especially if you look at them a little later. The other reason for using version control is that it may actually help you just to land your next job. If you look at the current job market, you will find that most companies use some version of version control. This could be, for example, GitHub. Here's some of the top companies using GitHub. This could be Subversion, a slightly older version of version control. And these companies don't just use it for software development. That's probably one of the main uses. They also use it for managing their data, their collaboration, and their workflows. Let me tell you 5 reasons why I use version control. First one is simple: mistakes. I make mistakes, everybody makes mistakes, and it's just part of being a human being. And if you don't plan for mistakes, you really plan for failure, lost information, time, and money, and who wants to do that? The other reason is backups. We want to make sure that we back up what we're developing carefully, so that in the case when our machine stops working because it's too old or dropped, or if there's some other catastrophic event, we can't get to our machine because of a pandemic or a hurricane, we can simply use clones of the data or check out the data in an online repository and keep on going wherever we are. And so I push all my version of the software, papers, data sets I develop to either iCloud, GitHub, or Overleaf to make sure that I have access to them no matter what happens to my main computer. Next reason, and that's relevant to the CBB, is teamwork and collaborations. If you're like me, you probably had some examples in the past where you worked in a team, you worked on a joint document, and you either emailed the document around, you worked on something, somebody else worked on the same section, or you shared a file on some virtual drive, and the work you've done was simply overwritten, and there was no recourse to figuring out what you've done, and then you got to start from scratch. Version control allows multiple people to work on the same file. And it allows you to do it in an organized way. It doesn't guarantee that you don't have any conflicts with each other, that one person doesn't change something, you change something else, and it doesn't actually match. But it allows you that you can actually merge those changes, right? And this is a lot simpler than having to redo everything because somebody might have overwritten your file. File maintenance. I've already mentioned that on the previous slide in that cartoon. Remember when we had those files with all names? Here just list data 1, data 2, and so forth. And that is, of course, a simple way of trying to do version control on your own, but it doesn't work very well because you don't have what you have in true version control, a way of adding comments to each of those files easily and messages about each version, which allows you to go back and forth and figure out which one is the right one you want to do, in which order were the files created, and which one is the one you want to really end up utilizing. The last reason, it's future-oriented. If you think about some of the software you've written or some data files you created, and if you want to go back just a couple of years and look at some of the older files, and you look at them, you'll probably ask yourself, who wrote this? This is simply awful. And so if you use version control, you will hopefully not just have the opportunity to have maybe some comments in the code or files, which you might have, but even if you don't have those, in version control, you have the commit change logs, and you can look simply through those and see, oh, this is what that is, this is how that emerged, that's the project I'm talking about, and you can use it better. So version control is useful. And so what is version control? Version control is simply a database that keeps track of changes to your files. And it does one step better. It actually allows you, for your files, to monitor how files change. You changed file 1, you can track deletion of files, and you can track that you added files. Once you have that, you can do the next step, even more important. It lets you undo any change. So it lets you unadd files. So file 3 is gone. It lets you undelete files. So you get to the previous stage where you have file 2 still there. And it lets you unchange files. And even more fun, it lets you even undo your undos. So in other words, if you undid something, you say, oh, I didn't want to undo all that, you can go forward and go back to your changed files and your deleted file. So this is simple version control. What I'm going to tell you more about, and what's more relevant for collaborations as part like our CBB efforts, is distributed version control. So taking care of your files and making sure that you can go back and forth is very useful, and there are various tools built into the operating system. I'm going to mention them. But if you work in larger projects, you want to use distributed version control systems because they let people and teams collaborate together. And so this works for software, obviously. This was one of the main reasons it was originally developed. It works for website. It works for data. I'm going to say a few things specific about that. It works for manuscripts, papers you write. And it's quite agnostic to any tool you use. It doesn't care what text editor you use. Some of my students still use BI. I feel really young because I don't. If you use Emacs, if you use Notepad, Word, or whatever you do, it all works. You can use any graphics program, file manager you want to do. The most important thing, it keeps track of changes of your file, and it allows you to collaborate. So this illustration is here for a website where it simply timestamps any changes you made and has comments in the version control system and the version of the snapshots of those files for each of those changes. So I'm going to tell you first about a simple type of version control, which you probably are already using, and if not, you definitely should be using. And that is simple version control for text files, presentations, spreadsheets, etc. And this is stuff which is typically built into your operating system and to some of the tools you are likely using already. So many of you have probably used Google Docs, and you can turn version control on in Google Docs. You can even put in comments to your versions. Most people don't, but you could. You probably use Dropbox that has some sort of version control where you can go back for at least the last 30 days of versions freely. And if you pay a few bucks, you can get back forever for any of the files you have. Apple has an iWork suite, which is this equivalent of Word, etc., which has version control. And here's some illustration of some of those. This is for Apple, where you can go back to any version you ever created. For example, for the slides I have here, here's Google Docs, and here you can see the comments on this side. And Overleaf is a version, a software package for manuscripts focused on LaTeX, if that's something you use, which also lets you do version control and nice collaboration with comments, etc. These work well for small group projects, and there's absolutely no reason not to use them. They ensure your data is backed up, it lets you work in teams, and it keeps track of all the changes. But I want to talk more about the version of version control, or the kind of version control you might not be using, which is distributed version control. And the software I'm going to talk about is called Git. This is a version control package which was developed, I believe, in 2006, and is completely open source, so that means it's going to be widely used across the community. It's future safe. This isn't going to go away anytime soon, and you don't have to pay for it. And it is really designed to work with collaborators and teams. And so here's an illustration on the right where we have a repository for a project. That could be a data set, it could be a software tool we're building, and that might be housed on some server. This could be GitHub, Bitbucket, GitLab, anything else. And we can replicate, check out that repository onto the computer we are using. This could be Melissa, Joshua's, or Alicia's computer. And then we have our own repository. And then we have a working copy of any of the files, and we can edit the files to our liking. So we update our files, we commit our changes to repository, and once we're happy with those changes, we'll talk more about that, we can then try to put these changes back into a repository, which you do through a pull request, where you communicate with your team workers to make sure that these changes are actually used. I want to also mention briefly where the name Git comes from, because in the English language, a Git is not necessarily a nice person. And so Linus Torvald, who wrote Linux, the operating system, was the one in 2006 who wrote the software Git because he didn't like some of the previous version control packages. And when he was asked for why he named it that, he simply stated, well, it's very simple. I'm an egotistical bastard, and I name all my projects after myself. First Linux, his name is Linus, and now Git. So how do you use version control? The next part of the presentation, we're going to talk a little more practically, what are some of the tools and how do we use it? How can you actually try using it? And I'll talk a little more about how we use it for data. So as I mentioned, it lets you keep track of changes in code, data, text. It doesn't let you keep track of changes in binary files or in images. It lets you, however, keep track of the binary files or the images itself, and you can comment on those. But inside the files, there is no way of controlling which bit, etc., changed, etc. And for working in teams, you should be using Git. If you want to share your software or data and also make it freely available at some point, there's services like GitHub, Bitbucket, and others, GitLab, which let you do that as well. I'm going to talk today about GitHub because it's the one we're using, but some of the other ones work similarly. So Git is going to be installed on your local computer. As I said, it was developed in the early 2000s. And what Git does better than some of the previous version control tools, it lets you do branching. I'll talk about that in a little bit more detail. So this is what you're going to use on your computer. But if you want to have a remote repository where you're actually going to store the data and later make it available, GitHub is a repository hosting service. There you can share the tool with others. It allows you all kinds of powerful tools. And it's completely cloud-based. That means you're also safe if your computer or anything else ever dies. Here's a snapshot of what GitHub looks like. This is just our GitHub repository where we have a number of software packages we're developing, and those are all freely available. You can also have private repositories on GitHub if you're not ready to share your development yet. So Git. So Git is a tool you're going to have on your computer, and it's a workflow software for project development. So it lets you work in teams if you want to work on a project which involves digital data. You can try out new ideas, you can experiment and contribute to changes, and it's really developed for team science where you share ideas, comment on other people's contributions, and where your work is reviewed by your collaborators before it goes back into the main trunk of your data package or software. And so the version control part lets you really document the history of your software or data development. And so the basic idea is quite simple. We all work in directories, and you have your files in your directories. Then you use the git command git add to add it to a staging area, and then you can commit it to your own repository. You can go through that cycle as many times as you like until you're happy, and once you have updated your repository to a version you want to share with others, you can go out and do a pull of the community and merge, after discussion and testing, your changes to the main repository. So I'm going to go through briefly the workflow for GitHub and then talk briefly about data. So the GitHub and Git workflow really starts out with creating branches. This is where you can try out those new ideas. You take the code or data tool you have online, you'll create a branch. You do your changes, you play with it, you do various commits and say, okay, I changed something, I added something. These are all individual commits changing your branch. Once you're happy or you want to start discussing things with others, you do a pull request. This is really talking to your team of developers and getting their input. You should do that not after you finished your project, but also if you just have some screenshots, ideas to discuss, when you're stuck or need advice on what you're doing, or when you're with somebody to actually review your work. And when you do that, there's a discussion period for your project. And so people will comment on your code, on your data. It may not match the data style you had all agreed on. There may be something missing. Maybe you should add unit tests if you have software, or everything just looks wonderful and you should be applauded for that, and it should be merged. You can then deploy your changes. You can use tools like Travis CI when you use software to actually run automated tests like the unit tests I mentioned, or you can share the data in a way already before you merge it back into the master branch, which is the last thing in the GitHub workflow. And then you start over again with a new branch, adding new features, new data, etc. I'm going to skip this part here and just jump ahead. I have a few slides here where I'm going to talk about how to actually create a Git repository. I leave them in the lecture notes online, and also have a link to a more advanced detail, but I want to really talk about Git and GitHub for data. I'm going to first mention something about data patterns and what kind of data it's really good for. Git and GitHub work best for small to moderate large data sets. So data sets which are less than 10 megabytes or less than 100,000 rows in a spreadsheet work well. If you get into the millions or hundreds of millions of data entries, Git may not be the optimal tool for that. But most of the data sets we're dealing with are typically small. It's optimal if you store the data in a line-oriented text. So that it's human readable, and a specific format that's widely recommended is comma-separated variables, which is used by all spreadsheets and all kinds of tools, including Python and other software packages. And so the individual units of data in your set are rows of table or individual cells will correspond to a line in your data set. And so the way to work with those kind of data sets is very simple. You store the data in a folder, and we'll use Git for version control. So if you update your file, if you add new entries to your CSV file, if you add new columns, new types of data, etc., you commit those changes and you comment on them so that anybody data can see what happened to the files. And then you can turn that data collection into a simple data format, and you have to add a couple of files to that. One is called the data package descriptor, so-called JSON file, which is going to provide the information about under what license do you have that data, where's it from, and what is the format of the data. It's called a schema. Computer scientists often have nice words for different things, but really it just means what's that format of that file. So column 1 is a number, column 2 is a string, column 3 is a floating point number, column 4 is a JPEG file, etc. And then you can add also to that data format any kind of scripts you need to process, to make plots, to analyze the data, and then you put in your folder. Once you have that in your folder, you've got a full data package you can share with GitHub to any user out there. So here's an illustration of what you need to have. You need a data package.json. You need your CSV file, preferentially put them in a folder called data, and you can put any CSV file you want in there. And then you definitely want to have a readme.md file. MD stands for Markdown language, a file which is a formatted text file which tells you and the reader what that is. And then on this folder with those 3 files, you do your Git to control any kind of versions you have. And so here's an illustration of what that data package.json looks like. This is a typical JSON format, looks like XML type format, and where you just define certain things. You define, for example, what is the name of the data, the title, license, what the sources were, resources, and then below that you would put the so-called schema, the formatting information. The good news is that in order to create these files, there are Python tools. There's actually a Python package called data package, which lets you deal with those JSON files and those CSV files. So for example, in order to read your data file into the computer, it's just a 2-liner, or you've got this 3-liner in Python, and you've got your whole data read in, and you can use this set of lines to read any data file out there that other people have published as well. So here's an illustration. If you want to look at some examples what these data packages look like, You can go to GitHub/datasets, and here's a dataset page I pulled up. It's somewhat current, the one they have, and it's exactly like I just described. It has a data folder in there. If you would open that up, there are the CSV files in there. It has some scripts which show you how to read the data. That script is typically similar looking to what's here. There may be some other entries in there if you do something specific. And there's your JSON file which describes what's in there. Then that readme.md file is actually illustrated below. This is simply that text description telling you about the data, where it's from. So with that, I think I'm at the end of time. I want to make sure that I leave you also with a couple of examples and resources so that you can actually play around with some of these tools and description I outlined here for you. I do recommend anybody wants to try out GitHub to look at the software carpentry link I have here, the Git novice one. It takes you probably about an hour and a half to go through that on your computer, installing Git and running those examples and to get a hang of it, how you check out files, your repositories, how to make changes, add those changes, commit them, how to do a pull request, how to undo changes and stuff like this. In addition, there's some nice GitHub tutorials. Here's a snapshot of their website with all these GitHub tutorials. There's some best practices you probably want to look at some point to figure out, am I doing the right thing? And there's also a very powerful tool called GitHub Desktop, which is a graphical interface to GitHub, which lets you a lot of the things just visually and in a very nice way also linking to all the files you have. For managing data specifically with Git, I find these two websites particularly useful. There's the data packages website here, and then here's some example data sets I mentioned on GitHub, which let you kind of take a look of what's out there. So I recommend you give it a try. You may actually like it, and it may really change the way you work. And you look back a few years from now and say, this really helped me deal with the large data sets and made my collaborations so much more fun. Thank you very much.
Thank you. We have time for a question or two.
Hi.
Michelle.
I don't have a question, but I just shared a link in the chat. Thank you for the talk, Richard. But I shared a link there's a GitHub student developer pack that gives students free access to a lot of developer tools. And I just wanted to share that as well.
That's wonderful. Thank you.
Mm-hmm.
Hi, Richard. It's Steve. Could you comment on security?
Security. Excellent. So first of all, once you put your stuff on GitHub on the open, there's no question about security. The security exists that nobody unauthorized can change your master branches. So your data is safe in the sense from anybody breaking in and changing it or messing it up. It's visible for everybody, so it's not hidden if it's in the open site. If it's a private repository, you authorize as a Git repository owner anybody who has access to the files. So in general, I have not heard about any security issues along those lines of passwords being stolen from GitHub, etc. Git itself, if you use Git on your own computer, the security is exactly the same as for all your files. So if you encrypt your drive, it's going to be all encrypted. You have to have a proper password and can do other kinds of authentication to protect your computer. There's no additional security requirement I can tell about the Git part of things. On GitHub, when you transfer files back and forth, it's the same thing as always. Once files get transferred to other sites on the internet, and GitHub is a company which is owned by Microsoft, you of course at the whim of the security of those companies, but it doesn't seem like, since it's designed open source, any kind of security flaw gets fixed very quickly, just as in Linux and in OpenBSD, the basis of the Apple operating system. And in my experience, it's pretty secure and safe in that sense. Do you have any other specific concerns?
No, I just thought you should comment on that, because if somebody got control of a higher level depository, they could change things which might feed back. Yes. I mean, this sounds very perfect.
Yeah, you have logins on GitHub, and you do use two-factor authentication if you want, and all these things. But it is up to you to make sure your passwords are secure and not shared with anybody else. And you're the one who gives access to your repository. And when anything gets merged back into the master branch, this is the one on the repository actually, you have the final say so there's different levels. There's an owner of the repository, and then there are, I forgot the exact term, but there are main users of the master users, which can also allow merging and stuff like this. So it's your team of developers which has full control. The good news is, if somebody messes it up, you just use the version control and go back to the previous version. It's not a big deal. Yeah, but I mean, it's something you got to be aware that you don't do stupid stuff, just like with anything software and data. Thanks.
Hi, Richard. It's Lippy.
Hi, Lippy.
Do you have a suggestion for sharing really large data sets, like tens or hundreds of gigs?
Tens or hundreds of gigs. Well, definitely not GitHub. They won't like that.
Right. Yeah.
It's beyond the capacity and it's not free. So, and when you say sharing, what specific? I mean, you got to be more specific. The community you look for.
Right. So So I think something that my group is looking into is wanting to make, so I'm doing some surrogate model training. So we have neural networks that are trained on huge amounts of data, and we want to be able to, once a model is published, we also want to make the training data public. So someone could look at the training data and see what was pulled out of there. So, and this training data can sometimes have particle information, which means that you have thousands of particles and thousands of samples of thousands of particles. So how can you actually make that available? Is the only way to try to upload it on some kind of personal website and then share that link, or what's a good way to do that?
Yeah, so there are some, so when you publish a paper these days, and it's in a computational journal, there are specific repository designed for where you put the data that you have. And so they will give you gigabytes, many gigabytes of storage space. They're probably not going to be in the terabyte range, but 100 gigabyte is not the end of the world for those. So I try to think right now about where we put some of our data for that thing. We have our data on our own website, that's the first place, but then we typically upload it to other places as well. And so there are some data repositories out there which let you do that. So for example, if you publish with Scientific Data, which is, I believe, a science journal, they specifically have repositories available where you put your data, and 100 gigabyte is not the end of the world for them.
Okay. So what about—
And those journals are very easy to publish in because they want to collect the data so people can use it. So it's really just, here's a data set, you describe it, you upload it, and they will keep track of it because you pay them a fee up front. It's a publication fee. It's an open access journal. And the publication fee will ensure that this is there for the long term. There are other solutions like this, and if you send me an email, I'll talk to my students, also my group, and we figure out what are some of the other options you have. Yeah.
Yeah, that sounds good. Because I mean, some of the models we're working on themselves are not publishable. They're just, it's just a model that could be used or could be iterated on. So I'm not sure that I could build a whole paper and then publish it.
No, but the Scientific Data Journal, for example, publishes just data sets even. So even just say, here's a data set, we machine learn, and here's some plots on it. But you should really use it for some other machine learning, whatever. They're perfectly happy.
Oh, okay, cool.
So
okay.
We're working with Google on a data set right now, which is going to be just snapshots from MD simulations because we want to motivate people to work on symbolic regressions for energy landscapes. And so the data set is somewhat boring and somewhat straightforward, but we want to motivate the community to do that. And they will publish that, but there's no question about that.
Oh, great. Okay. Can you share the link?
So this is, I believe, called Scientific Data. But if you send me an email, I'll dig up some more information. Yeah.
Thanks.